Dear student, welcome to this session in which I am discussing experiment number 4. This experiment is related with RAR sample test for proportions. Normally, proportions were used when the attribute or the quality is known. See the example 1. The proportion of defective items in a sample of 36 is found to be 0.07. Test the hypothesis that the population proportion is P against the alternative that P is greater than 0.05. So what is given in this case? In this case, the sample size is known. See, this is 36. And again, the proportion of defective items is known. So defective is the quality of item. So therefore, the proportion, we can use the proportion test. 0.07 is the given value. So what is the population proportion? Population proportion is 0.05. And the alternative hypothesis is right-tailed test. How to solve this example? To solve this example, first, normally we start with our aim. What is the aim in this case? The aim in this case is to test the population proportion is 0.05. So that means to test H naught, P is equal to P naught. This P naught stands for the proportion value for hypothetical proportion value. So P naught is the population proportion value 0.05 for the given sample. What is the formula? Formula is Z is equal to P minus P naught divided by square root of P naught Q naught divided by N. Follows normal 0, 1 for large sample case. So the value of this Q naught. So Q is 1 minus P. What is the value of Q? So Q is equal to, so the value of Q is normally taken as 1 minus P. So 1 minus P is nothing but P. P is the probability of success where Q is the probability of failure. So likewise we can understand. What is the procedure? The procedure is sample size is known, sample proportion is known, population proportion is known. Then what to do? So the procedure starts with the procedure starts with by taking the H naught value as 0.05 and then finding the alternative hypothesis. The alternative hypothesis is known to us. So the alternative hypothesis is P greater than 0.05, right? So therefore it is a right-tailed test since the value is greater than. So this, if the value is greater than, we can take right-tailed test. If the value is less than, we can take left-tailed test. If the value is not equal to, then that is two-tailed test. Now, under H naught, P is equal to P naught, the test statistic becomes. So we know that the test statistic value is this, right? And also we know what are those values. Those values are sample size, sample proportion, and population proportion. All these values are known to us. So once all these values are known to us, we need to put these values. If we put these values, what we are getting? So substitute all these values in the equation. So what we are getting? See, this is P is equal to P naught. This is value. So 0.07 is the sample proportion value. This is my population proportion value. And Q naught is my 1 minus P naught. So therefore 1 minus 0.05 is 0.95. This should be multiplied with 0.05 since it is a multiplication and divided by the value 36. What we are getting? If we simplify this, we are getting this value as 0.55059. So therefore my calculated Z is 0.55. I have calculated this with the help of software. So if I put all these values in the software, what I am getting? So I am getting Z value as 0.56. So that is same as 0.55059. And what is my alternative hypothesis? Alternative hypothesis in this case is P greater than 0.05. So my level of significance is 0.05. See, it is mentioned here. fix the level of significance as alpha is equal to 0.05. So I have calculated this value. Now I, I have to locate the table value. So table value is located for which one? So this is probability mod z is greater than z alpha, which is equal to alpha. So table z is table z alpha. So in this case, I am not taking this value as alpha by 2. Why? Because it is not a two-tailed test. Since it is a right-tailed test, it is mentioned here, it is a right-tailed test. So therefore, only alpha is taken. And what is the value of alpha? Alpha is 0.05. And this value comes out to be 1.64. So I will show you how this value is 1.64. See, this is a standard normal table. In the standard normal table, what value we are looking for? So we are looking for 0.05. Where it is 0.05. See, this is 0.0505. So this is close to 0.05. And what is the corresponding z value? So this is the intersect value. If you take this value is 1.6 and the uppermost value is 0.04. If you add both these values, 1.6 plus 0.04, so that comes out to be 1.64. Since we are looking the value below this, therefore the value comes out to be negative. But whether it is a one-tailed test or two-tailed test, we are taking this value as absolute value. If you take this value as absolute value, even though it is minus 1.64, it should be taken as, since it is a absolute value, see, this is absolute value mod z. Therefore, this value, even though it is minus, it should be taken as 1.64. So calculated z is less than table z, therefore we can accept H naught. So what is accept H naught means? A sample may be regarded as coming from population with proportion value as 0.05. So that is our conclusion. Likewise, we can solve the second example also. What is second example? So what is the aim in this case? To test whether it is reasonable to assume that 20% of the oranges were bad. The values are given. H naught is P is equal to P naught equal to 20%. So the formula remains the same. This is the same formula that we are using because the value of n is 64. So n is 64 means it is a large sample test. What is sample proportion? So sample proportion is P is equal to X upon N. What is the value of X? So X in this case is 14. If you read the example, 15 oranges were bad out of 64. So sample size is N. The number of oranges bad were X. So what is the proportion? So proportion of bad oranges are 14 divided by 64. And that comes out to be 0.2121875. And what is the proportion value of population? Population proportion value is 20%. The test is two-tailed test. The level of significance is 0.05. Apply this and put the values. If you put the values, what we are getting? We are getting the value of Z as 0.375. And then we need to compare this value with Z alpha by 2 since it is a two-tailed test. So what is the Z alpha by 2? The value of Z alpha by 2 in this case is 1.96, as we have seen this in our earlier video. So the value is 1.96. I have shown this in my earlier video also. So calculated value of Z is less than table Z except H naught. Means what? It is reasonable to assume that 20% of the oranges were bad. So in this case, we can solve the examples or test the hypothesis whenever there is a single sample and the proportion we are interested. Thank you very much.